Hello and welcome to the next CloudScale screencast. In this screencast, I'm going to show you how to use the static spotter export functionality that can later on be used to guide the dynamic spotter for a goal-driven detection of anti-patterns. So what I'm going to show you is how to export with static spotter. For that I have prepared you a minimal example that shows you how to extract the system and how to detect a potential anti-pattern, as well as to use the export functionality. So the minimal example is a small Java project I've opened already here. You see there's a main class. The main class includes just one main method where a client object is instantiated and the operation start is called on this client object. If I go inside the client class and have a look at the start operation, you see that this is a synchronized method and some things are executed inside. The important thing for us is that this method is synchronized, which can be detected by the static spotter to identify a potential one-lane bridge anti-pattern. Yeah, so control and data flow may have to go through the start method because it's synchronized. Only one job at a time can pass this method. So therefore, it can potentially become a one-lane bridge. So the task of the static spotter is now to detect that. For that, I would first call the extractor. For that, I first start a discovery with Modisco. So I right-click on the project, go to Discoverers, and select the Java Discoverer. Here are some options I have to set. For that, if I don't know the options, I would go to the CloudScale webpage, go to download, and here I also find a download link for the user guide. So if I download the user guide, I can also look up how to set up this extracting. For that, I have to go down a bit to the extractor, page 42. On this page, I find a description of the extractor and how to use it. So here is the usage description, and here are the settings I just opened. So it states that I have somehow to select excluded element regex and included element regex. That's optional. I don't have to do that. Refresh source code before. I have to set that to true, such that I get directly an update that's already set to true, and serialize and target and deep analysis have to be set to true as well. So deep analysis is already true and serialized target is also true. With that, I can start discovery. Modisco creates an abstract syntax tree. You see that in these files here. These files are the input to our extractor, which can be simply configured in a SolMux1 configuration. I pre-configured that here, so I set the project I just opened and the just extracted Java to KDM file. I also set some configurations here. That depends on your project how you configure that, but stick to the usage guide for a detailed description for that. So if I run that, I extract a concrete model out of it. The output is here. I can also have a look inside the model. I can open it in a diagram. Here we see that the client class has been extracted to a component, and the client called some service That's something we would also see if we look inside the client class again. Here is a service object. It had been instantiated after constructing the client, and then some service is called. So we see this dependency here from the client. There's a dependency to a service, and there is a dedicated service component as well. What we do now is, on this model, we run static anti-pattern detection. For that, we go to Reclipse, say start structural pattern detection. We configure it appropriately, and again, if you don't know how to configure it, just stick to the user guide. There's a concrete walkthrough that guides you to these settings. So here is also the pop-up you've just seen, and some other configuration settings you need to set up. So I pre-configured that already to use our CloudScale pattern catalog and to use the just extracted model as an input for the pattern detection. I press finish and the pattern detection starts. It's already finished here. I switch to the annotations view and I find out that different patterns have been detected. Ceph methods, executive allocations have been found, find methods, find primary components, and synchronized method patterns have been detected. Now comes the new part. If you have a look at this synchronized method, you find out that there is a synchronized method, and so the question is where it is, and because this can become a potential one-lane bridge, and we'd like to guide the dynamic spotter to this concrete synchronized method that was detected. What is now new is that we can right-click here and say export annotation. And here we can, we can set an export location. For instance, test.scope on my desktop. Then we get a message that we successfully exported this scope specification. So if I now open this new this test scope document in a text editor, I did that now. I see that there is just one line exported. That's because I just exported one method. You could also export several, like this, and then choose export. So I just exported one synchronized method detected, and it points me to the package of my example project, and in particular the client class, and inside the client class to the start method. So as a reminder, this is the package that was detected. Below you see it's also the class that was detected. And here the start method was chosen because it was synchronized. That was exactly the pattern we detected. And we now provide a mechanism to automatically export, so to say, pointers to the synchronized method. And these pointers, they can be read by the dynamic spotter for a guided detection of one-lane bridge anti-patterns, for instance. Simply have to go to the dynamic spotter configuration and set this file as an input for guided detection. We will provide a separate screencast on how to configure the dynamic spotter with these exports. Thanks for your attention.